بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام عليكم ورحمة الله وبركاته. اليوم سنتناول درس جديد في مادة الاستاتيكا وهو بعنوان Exercise of Couple. Welcome my dear student in our math program on secondary 3. Today we are taking new lesson. It's titled Exercise of a Couple. My dear student, we know that from the two previous session, the couple is two forces equal in magnitude of the direction. The action of this line don't lie on the same straight line. And we know that moment of the couple equals the product of the force times the distance between the two forces. And also we know the direction of the couple anti-clockwise is positive, clockwise is negative. After that, my dear student, we know that the couple formed from three sides of a triangle in cyclic order. The moment of this couple equals twice area times the k, or the constant ratio. Now we are taking the exercise about the couple. My dear student, look at the first example. A, B, C, D, E, O is a regular hexagon. What is the meaning of regular hexagon? Excellent student. Regular hexagon, all sides are equal in length, all angles are equal in measure. Measure of each angle is 120 degrees. Read again. A, B, C, D, E, O is a regular hexagon. Forces of magnitudes 10 root 3, 6, 10 root 3, 6 Newton act along AB ray, DB ray, DE ray, AE ray respectively. Prove that the system tends to a couple and find the magnitude of each couple. Find also magnitude and direction of the two forces which act along EB and AQ such that the system will be in equilibrium. Solution. Look at the opposite figure represent regular hexagon AB, CD, E, O. AB, CD, E, O. Look at the forces which act at AB, 10 root 3. The forces which act at DE, 10 root 3. Also, two forces, each one is F, which act at AO and EB. And we have two forces, 6 and 6 Newton, which act at AE ray, DB ray. What you notice? We have two equal forces, 6 and 6, form a couple equal in magnitude, opposite direction. What is the moment of the couple? Find the value of moment by product 6 times the distance AB. Maybe AB equal length, the side length of regular hexagon. At the first, if we put AB equal L centimeter or the side length of regular hexagon, we deduce that AB equals L, but BD equals L root 3. Then AX equal L sine 60. Root 3 over 2L. Look at, my dear student, 10 root 3, 10 root 3 form couple. The moment of this couple equals F times L, or F times distance. What is the distance between the two forces? AE. Then 10 root 3 times L root 3 equals what? 30 L Newton centimeter. Remember, my dear student, unit of a cable Newton centimeter, unit of the force times unit of distance. The force is unit, its unit Newton, the distance centimeter, the moment Newton centimeter. Second cable, look at the two forces 6 and 6. The two forces equal in magnitude, opposite in direction. The moment is negative 6 times AB. Why negative, mister? Excellent student. Negative. Why? Because with clockwise direction of the cable or direction of the two forces 6 and 6 with clockwise, with negative sign. Therefore, negative 6 times L. AB is L, the side of regular hexagon. This M2. M equal M1 plus M2 equal 24L. Therefore, the moment F which act, the moment of the couple of the two forces F and F which act at AO and EB equals what? F times AK. What is the value of AK? AK, the distance, this distance between the two forces. What is the value of AK? Excellent student. AK opposite angle 60. Look at in triangle ABK. Look at triangle ABK. AK opposite angle 60. Then AK over AL sine 60. Or AK equal L sine 60. Sine 60 equal what? Root 3 over 2. Then AK equal root 3 over 2L. We deduce that the force F by substitution equals 16 root 3. Now we are translate to another example. Three forces are completely represented by the sides of equilateral triangle ABC, taken the same way round and with drawing scale 1 centimeter to gram width. Each 1 centimeter represents 2 gram. If the length of the side of triangle equals 30 centimeter, find the magnitude of resultant couple. Look at solution. ABC is equilateral triangle, side length equals 30 centimeter. F1 acts at AB, F2 acts at BC, F3 acts at CA. What you note? Three forces act at three sides in cyclic order. Then what you mean? If the ratio between the force and the side are constant, represent couple, moment of couple equal ratio or K times twice area of triangle. Then the scale between the side and the force equals 1 over 2. The side L, the force F, 1 over 2. Therefore, the constant K, the ratio between the force and side equals 2. They are the same direction order. What you mean? F over L, F1 over 30 equal F2 over 30 equal F3 over 30. Each one equals 2. Then we deduce that three forces are equal and the moment of the couple twice area of a triangle ABC multiplied by the constant ratio K. Then we know that twice area of a triangle have side times side sine angle between them. BA half times BA times BC sine 60 times constant 2. Why? Because the couple, which represent by 3 forces in same cyclic order, equals, or its moment, twice area of triangle multiplied by K. What is the K? Constant ratio. Therefore, my dear student, by substitution about BA and BC, each one equal what? 30 and sine 60. Therefore, the moment 900 root 3 gram weight centimeter. Now we are translate to another example. ABC is an isosceles triangle in which AB equals AC equal 5 centimeter, BC the base equal 8 centimeter. Forces of magnitudes 20, 32, 20 gram weight act along AB ray, BC ray, CA ray respectively. Prove that the system of forces equivalent to a couple and find the norm of couple moment. And the magnitude of the forces perpendicular to BC and its end for the system of all the forces to be in equilibrium. Solution. Look at, my dear student, in the opposite figure we have ABC is isosceles triangle. The side lengths AB equals AC, each one 5 centimeter, BC equal 8 centimeter, AD perpendicular to BC. We know that, my dear student, if we divided the force 20 over 5, 20 divided 5, which act at CA, the ratio equals 4. Also, the force which act at AB is 20 divided by 5 equal 4. The force which act at BC is 32 divided 8 BC equals 4. What you know? It's constant ratio. And we have 3 forces which act along 3 sides of triangle in cyclic order. Form a couple. Form a couple. Why? 3 forces act along 3 sides of a triangle and there is ratio constant between the force and each side is 4. What is the moment of the couple? X and student. The moment of the couple equal twice area of triangle times K. What is the K? Is ratio. In this case equal 4. Remember, my dear student, AD, the height of isosceles triangle, equal what? 5 square minus 4 square, Pythagoras. AD perpendicular to BC. Why? Because AB equal AC isosceles. Therefore, AD perpendicular to BC, AD equal 3 centimeter. Area of triangle have base times height. We know that area of triangle have times 8 times 3. Equals half times 8 times 3 equals 12 centimeters square. Therefore, the 3 forces are in the same cyclic order. The ratio K equals F over L. Don't forget, my dear student, the ratio is K ratio between the force and the side, not side of the force. Remember, it's very important. K, the ratio between the force and the side. F over L, not L over F, equal 20 over 5 equals 32 over 8 equals 20 over 5 equals 4. Then the moment of the couple twice area multiply K. 2 times 12 times 4 equals 96 gram weight centimeter. Remember, my dear student, if we have two forces which act at B and C in the opposite figure, these two forces form also a couple. The distance between them equals 8. What is the value of F? It is very easy. Why? Because the equivalent to couple. We have two couples. The first couple 96, second couple equals F times 8. Then it is easy to find the value of F. System equilibrium, summation of two couples moments equals 0. Then F equals 12 gram weight by divided the moment of the first couple 96 divided the distance between the two forces 8 equals 12 gram weight. This is the value of F. Now we are translate to another example. ABC is a triangle in which AB equals 13 centimeter, BC equals 14 centimeter, CA equals 15 centimeter. Forces of magnitudes 39, 42, 45 Newton act along AB, BC, CA respectively. Prove that the system of these forces equivalent to couple and find its moment norm, and find two parallel forces acting at B and C perpendicular to BC to be equilibrium with the previous forces. Solution. Look at, my dear student. We have three forces. The first act at AB, 39. Second acts at BC, 42. Third acts at CA, 45. If we divided AB over 13, the value of AB, the ratio equals 3. Also 42 divided 14 equals 3. 45 divided 15 equals 3. This is constant. It is easy to find the moment of this couple. Why? Three forces form a couple, act at three sides of triangle in magnitude. Moment is K multiply area of a triangle. To find the area of triangle ABC, we have three sides. We have three sides only. We know that area of triangle have base times height, have AB sine C, or have AC sine B. What is the angle? We need measure of angle to find the moment of the couple. In this case, my dear student, we find measure of angle C by using this rule, cosine law. Cosine law from the second or the previous year cosine C, A squared plus B squared minus C squared over 2AB. Remember, A squared represent the side BC. B squared the side which opposite angle B or AC, and so on. Cosine C, this rule from secondary, to find measure of angle C, we use A squared plus B squared minus C squared over 2AB. Cosine C, 14 squared plus 15 squared minus 13 squared over 2 times 14 times 15 equals 3 over 5. This is cosine C. Therefore, by using sine squared plus cosine squared equal 1, we find sine C 4 over 5. Area of triangle ABC have AB sine C. Therefore, area of triangle ABC 1 over 2 times 14 times 15 times 4 over 5. Answer is 84. This area of a triangle. What is the moment of this couple? Moment of couple twice area times constant ratio. Look at, my dear student, the forces are in same cyclic order. What you mean? The constant K, F over L. 42 over 14 equals 45 over 15 equals 39 over 13 equals 3. Constant ratio. Therefore, from 1 and 2, the moment of couple twice area of a triangle times constant ratio K equals 2 times area 84 times constant ratio 3 equals what? 504 Newton centimeter. This is the moment of a couple. The second required how to find the force F which act at C and B perpendicular to BC. We know that in equilibrium, sum of two couples must be equal 0. What is the second couple? F times BC. BC, we have length BC equal 14. Therefore, my dear student, F times BC equal 504. Why? We have two couples, summation equals 0. Then F in this case with clockwise is negative, but by divided 504 divided 14, find the value of F equals 36. Therefore, we deduce that, my dear student, the value of F equals 36. The two forces which form the second couple, 36 to 36, which act at C and B. Then we deduce the value of the force which perpendicular to BC, two forces, each one 36 Newton. This very important example. When we find three forces which act as three sides of a triangle in cyclic order, the ratio between the force and the side is constant, represent a couple. We find the moment of the couple by using twice area of triangle multiply constant k. What is the k? Ratio between the force and the side. After that, we know that the two forces F and F which act at C and B equivalent or in equilibrium, then summation of two couples must be equal 0. Then find the value of the force which act at C and B by using division of the moment of the first couple among the distance BC 14. The answer is 36 Newton. Then the force is 36 Newton. My dear student, by the end of the lesson, we know that the forces which acting along three sides in cyclic order of a triangle form a couple. Its magnitude twice area of triangle multiply the k or the constant ratio between the force and the side. My dear student, don't forget the couple is very important unit. How many units in static? We have 6 units. This unit number 5. The first unit friction, second unit parallel forces, third unit equilibrium, fourth unit is general equilibrium, fifth unit is a couple. It's very important unit to solve in final exam. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.